Yang dari India dah masuk hari ni. Huh? Participant from India kan?
Ada few. Join the meeting.
Ya Bu, kenapa Bu singkong? Iya Bu ya.
All right. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning, everyone. Welcome to a dialogue on research and practice in rock engineering. So, on behalf of the organizer, I would like to welcome all the participants. We are still receiving some of the participants online. So, we are expecting to receive about maybe some of you will be inviting very soon. So just very brief, the dialogue on research and practice in rock engineering is co-organized by the International Society for Rock Mechanics and Rock Engineering, Society for Engineering, Geology and Rock Mechanics, SEGRM Malaysia, Indonesian's Rock Mechanics Society, IRMS, International Associations for Engineering, Geology and the Environment. So I think it's a great pleasure to invite all of you to our dialogue today. Very exciting to welcome all the speakers, panelists on the screen. So it's the first ever event co-organized between the professional bodies in Indonesia and Malaysia. We are greatly inviting all the professionals, students, engineers, practitioners, decision makers to this dialogue. So without further ado, I think we are having some housekeeping. So I would like to invite all the participants to ask questions. So we have three cycle or three part this morning. So the first part will be the welcoming. The second part, there will be a short sharing session by our great panelists speakers from both countries, from Indonesia and Malaysia. And the third cycle, we would like to invite all the participants to ask questions or to share some of your views and opinions for the benefit of our society, particularly dealing with rock engineering in these two countries and our region. So I think today we are happy to introduce you 6 panelists, both academicians, practitioners, and professionals. And we are also happy to welcome our great prominence vice presidents for Asia International Society for Rock Mechanics and Rock Engineering, Dr. Seno, and also Mr. Muhammad Faur bin Muhammad Amin, President for Society for Engineering, Geology and Rock Mechanics Malaysia. So I would like to invite all these two great prominent figure in our region to deliver an opening speech. Without further ado, I would like to invite Dr. Sesano to start the opening, please.
Yeah, can you hear me?
Yep.
Hello? Yep.
Yes,
okay, thank you. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. It is a great pleasure for us, not only for me, to have this kind of dialogue and the first time between two countries, International Society for Rock Mechanics, which is very interesting. In this morning, I'm very happy to welcome you all to participate in this dialogue. And the first thing I'd like to appreciate the members of this group who have been working very hard in making this event possible. And also I'd like to really appreciate for Associate Professor Ahmad Ashraf Ismail, long time no see, my friend. Mr. Abdul Rashid Javar, Dr. Rini Asnida Abdullah, long time no see. But I'm very happy for you to accept all of my invitation to be a reviewer in a journal. And then Professor Rido Watimena, my old buddy, my friend, and Associate Professor Imam Sadisun, long time no see. That was a long time ago when we started working for the your research in Kyushu University. Dr. Eman Widianto from Freeport. Are you there? No? Is it cold over there?
Still, Pak.
Yeah, okay. And then this event remind me to so-called joint symposium Japan Korean long time ago. The first time I was invited 1997 by the organizing committee, which inspired me. Why don't we also have this kind of event in Indonesia, in our region, like Malaysia and Indonesia, because we have the same background culture and we have a similar problem because the geological condition relatively the same, different to European. So I think we can learn from that past experience from Japan and Korea and to be applied in our groups, in our two groups here, which is very interesting. And then we started already a few years back, but today, so we see the realization of this program. And having said that, I believe what the most important thing for us at the moment, for our society, is to improve the knowledge of the first thing is about the suggested testing method or suggested method, which covers the whole principles to start with the observation and study, from which we will have numbers and information that can be start to go ahead with design. And then from the theory and practice, we can find the gap, you know. So what we are now responsible is to really make the gap become thinner between the theory and practice. So we don't talk about something that it is not practicable, but we also have to prove that what our approach from the experience has a basic theory. And it is very important for us. And then the last bit that I like to convey my message is that please take this opportunity while we are in the same culture, background, geological setting, so we can improve our knowledge together and be leading in our Asia Rock Mechanic Society, I mean the International Society for Rock Mechanics and Rock Engineering Society in terms of Asia Pacific. Although as my role in the VP Asia, I will have to also approach other countries. Like if it is possible, we'll continue with the relation between us together with Vietnam. So hopefully, after we have this, what we call later on Rock Never Lies 2021, we will have join again cooperation with other countries in Southeast Asia. So at the last, enjoy the dialogue and then have a good meeting, and please enjoy the same, what I'm saying is the same sense or the same experience in this event. So thank you very much for all of the organizing committee as well as the speakers. That's it. Assalamualaikum warahmatullahi wabarakatuh. Thank you very much.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Dr. Seseno, Pak Seno, for the opening speech. Without further ado, I would like to invite Mr. Muhammad Faur, a president of Society for Engineering, Geology and Rock Mechanics Malaysia, to deliver his opening speech.
You can hear me okay, right? Boleh?
Yes. Yep.
All right. Okay. Assalamualaikum and very good morning, right? To Pak Seno, Vice President, ISRM for Asia, and all our friends from Indonesia, we wish you a happy Independence Day, inshallah.
Oh, thank you.
Okay. So on behalf of this organizing committee for dialogue on research and practice in engineering, which is jointly organized by SEGRM and ISRM, International Mechanics Society Indonesia. Yeah, it is my great pleasure to welcome all the participants. Okay, so I hope although this dialogue is online in nature, basically sometimes it's not to our satisfaction when we do it online, okay, in nature, but we hope there's a lot of things to share, particularly on research interests related to engineering, geology, and rock mechanics. And I'm sure with the lineup of experienced and knowledgeable panels, this dialogue will be beneficial to everyone, inshallah. Okay. In fact, we planned for a number of activities with our counterpart from Indonesia, Indonesia Rock Mechanics Society in 2020. However, due to the present circumstances, they have been rescheduled to next year. For example, our MIRES have been shifted to 2021. They're going to be one of our main events, inshallah. Okay. Again, if I can put some point here with regard to the research. Okay. As far as our student is concerned, sometimes, you know, we tend to forget the basic things about fundamental of rock mechanics, which is rock testing. Okay, so basically, I think when you do, for example, the using the software and all this, our input data is equally important. So therefore, I believe we also should also focus on rock testing, which is important because whatever you fit into your software, it's greatly depending on the input data, the way you do testing, the way you understand rock properties, and the way you interpret the data. Okay, so in fact, it's supposed to be a brief introduction. Okay, so finally, our appreciation to both Board of Engineers Malaysia and Board of Geologists Malaysia for their support by granting the CPD hours for this program. Thank you very much indeed. Thank you very much. So hopefully everyone enjoy the talk today, inshallah. Assalamualaikum and very good day. Thank you.
Thank you very much, our president, for his opening speech. Well, on behalf of the organizer, we would like to thanks again to the vice presidents and presidents for the opening speech. And my name is Kamarul Azhari Razak. I'm currently a director of Disaster Preparedness Prevention Center of Malaysia, Japan International Institute of Technology. I will be your moderator today. We have a prominent, very experienced speaker. So I would like to very brief to introduce our speaker. We have both a balance today in terms of the practitioner, academician, scientists, and also a professional who are experienced in the field. So I think, as mentioned in the opening speech, by Pak Seno mentioned that we in this region we shared a common problems, issues and challenges. I think this dialogue aim to exchange our views, our experience, so that we can learn from the past, so we can prepare for the better in the future. I think we have 6 speakers today, and maybe on the screen, if you can project, well, say the first part of the sessions, we would like to invite all the speakers to introduce themselves very quick, shortly. And without further ado, I would like to invite our first speaker, very experienced professors who also a practitioner, to introduce yourself. Prof. Ridho, the floor is yours.
Okay, thank you, Pak Kamarul. Can you hear me, everybody?
Yes.
Okay.
Pak, silakan, Pak.
Assalamualaikum warahmatullahi wabarakatuh. Very good morning. My name is Ridho Watimena. I'm mining engineer by education. I finished my undergrad in 1991 and master 1996 from ITB, and I got my PhD in rock mechanics from University of Queensland in Brisbane, Australia.
Yeah.
I'm also a registered professional engineer in our institution for engineers in Indonesia. Currently, I'm the Dean of Faculty of Mining and Petroleum Engineering in ITB, Bandung, and also do some consulting work in the field of rock mechanics. That's it, Pak Kamarul. Thank you very much.
Terima kasih, Bapak, for a short introductory sessions. Now, I would like to invite our young genetic lecturer from University Science Malaysia, Associate Professor Dr. Muhammad Ashraf. Please.
Okay, thank you very much, Dr. Kamarul. Not very young, nearly 40 years old. Okay.
40 years today.
39, one more year.
Oh.
Okay, so my name is Muhammad Ashraf, Muhammad Ismail. I'm a full-time associate professor now at School of Civil Engineering. And my area of research and interest in geotechnical and also engineering geology, and also in rock mechanics and rock engineering. And I'm also the rock science representative for Malaysia since 2017. And rock science is one of the biggest company providing the geotechnical suite for mining, geotechnical, and also in civil engineering. Basically, my engineering, my education background, I'm graduated from USM, University Science Malaysia, in civil engineering in 2004. And then I'm continued my master under the JICA AUN SIDNET scholarship program at Gajah Mada University in engineering geology. And I think for Indonesian friends, they know very well my professor at that time, my supervisor is Professor Dwi Korita Kanawati. And my research work during my master mainly in slope. And I think in Indonesia, we know that the geological condition is very complex and also difficult. So I have a very tough time there to understand the geology knowledge. And then after that, I further my study for PhD under the JICA scholarship at Kyoto University. And my specialization at that time is mainly focusing on the underground construction for energy storage. And during that time, I'm involved for my research work related to the one of the biggest liquefied petroleum gas cavern in Namikata, Japan, and the site already have been the construction work have been completed, I think, in 2013, and now start operation. And I'm also a professional engineer in civil engineering and just received it this year. I think that's all. Thank you very much.
Thank you very much, Dr. Ashraf, for a short introductions and briefing. very a good career path, I believe. So I hope we can hear more story from him. His experience studying in Kyoto and his future interest in the geotechnical engineering, particularly rock engineering, inshallah. So next, I would like to invite our practitioner with more than 25 years experience as a mining engineers, also produce more than 40 technical papers. Incredible. So without further ado, Dr. Iman, the floor is yours.
Dibanding apa yang dia dengar.
Oke, terima kasih Pak Kamarul. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi.
Waalaikumsalam.
So actually, Pak Kamarul, I'm not having experience 35 years, but only 25 years. So basically, my name is Eman Widijanto. I am a mining engineer. So I have been working in mining industry for almost 25 years. Currently, I'm working as a geoengineering manager for Grasberg Mine, one of the biggest gold deposit in the world, PT Freeport Indonesia in Papua, Indonesia. Actually, my research interests are related to the mining engineering and also applied geomechanics for mining projects for both open pit and also underground mine. I think that's all, trying to be short.
Thank you, Pak Iman, for the introductions. Very short, but believe me, they have 100 years of experience to share with us. So if we count these 6 speakers' experience, it's about 130 years experience. I hope that I can manage to moderate with this huge experience for these short sessions. Okay, let's move to our next speaker, Mr. Abdul Rashid Jaafar. Please, the floor is yours.
Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Thanks all panels. My name is Abdul Rashid Jaafar. I have 28 years of experience, which 8 years is in oil and gas industry. Even though I'm in oil and gas industry, actually I work for geotechnical engineering actually, for foundation and offshore geohazard. I have a MSc in engineering geology from University of Hong Kong in 2006. BSc in geology from UKM and certificate for safety and health officer from NIOS, Malaysia. So I involved a few projects, I think notably Sungai Selangor Dam for groutings, instrumentation, as well as tunneling work. And for LRT, Putra LRT, the first LRT system in Malaysia, underground station, and various other highway project in Malaysia. Thank you.
Thank you very much, Mr. Abdul Rashid, who is currently a managing director of geomapping technology Sdn Bhd, Geomechanic Solutions Sdn Bhd, and also a president of Geology Society of Malaysia. So thank you, Mr. Rashid, for being with us today. And I would like to move quickly. Last speaker from Indonesia, from ITB, Pak Imam. Yes, please.
Can you hear me? Okay.
Okay.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Selamat pagi. It's my honor to be here in the part of this dialogue, and I put my title here. Actually, my presentation: Rocks Mechanics and Rocks Engineering, a Geological Perspective. I put also very maybe interesting sentence in my presentation today by Hawks in the course note about practical engineering. I think everybody knows. So I would like to emphasize here based on the engineering geological point of view in the development of rocks engineering, of course. Well, in this good occasion, I would like to also introduce my big family in our engineering laboratory. Engineering Geology Laboratory of ITB. And actually, we have a long journey within this laboratory, starting from around 90s. We have Pak Purbo Hadi Wijoyo and Pak Samporno that developed in the beginning of our laboratory. And actually, we have also milestone paper, which entitled The Status of Engineering Geology in Indonesia, 1970. It is written by Pak Purbo Hadi Wijoyo and published in IAEG Bulletin. I think it is very good paper to look at back the journey of engineering geology in Indonesia. And actually, I joined in ITB in 1995, starting developing engineering geology with my advisor, especially Professor Samporno and Mr. Bandono, and also they are my partner in the first period of developing engineering geology in Indonesia. And I put note also in my presentation that the engineering geology in ITB grew enormously, starting at 2005, and at 2007, we have a master education of geological engineering in the geological engineering study program. It is the big milestone in our study program also. And another very important milestone is regarding international accreditation from ASEAN, accreditation agency from German, with the opening of geotechnical emphasizing in undergraduate curriculum within geology engineering study program in ITB. And in the end of our group, we have young trop, Astiko, Randy, and Indra. I think they are very ready to increase development in research and practice in engineering geology, including rocks engineering in ITB. I think that's all my introduction. Thank you very much.
Thank you very much, Dr. Engineer Imam Sadisun, for interesting journey. As you can see on the screen, well, I think we would like to hear more story, more insight from you, Dr. Imam, especially when we're dealing with a future challenge for developing engineering geology in the industrial 4.0, inshallah. So I think, well, there's a five a speaker, and we have the only Iron Lady today. And without further ado, I would like to invite Engineer Dr. Rini Abdullah to introduce yourself. Please, Dr. Rini.
Rahim. Assalamualaikum. And good morning. Right, so normally we have what we call it as ladies first, right? But we can see here there's gender equality, right? So,
yes, we try to make it balanced, Doctor.
okay, it's good. Okay, so naturally my name is Rini Asnida. So it's hard for me to put it in the words. So I just show all the beautiful photos that I've gone through this rock engineering journey, right? So it's not about me myself, but it's also about the society SEGRM that I'm going through, okay, under ISRM, and also my research student and so on. Right, so to begin with, I'm actually a civil engineer. I'm the civil engineering graduate from University Technology Malaysia. Then I did my master also in geotech, okay. Then finally, I'm gone into the rock engineering when I did my PhD in Leeds University under supervision of Bob Fowell. So that's why I used to know all and fall in love with all this rock engineering family. I'm also the secretary of SEGRM, and What else that I said is about SCGRM is where putting all the not only rock engineering but also the geoscience from academic and from industry all together. Okay, so I find it is a good society at start, and now we have expand our collaboration with Indonesia, which is a good step forward to deal with. Okay, my research interest is more on the rock slope characterization, actually, where I did my study on the Penrhyn quarry, which is the biggest slate quarry in UK. And then when I returned back to Malaysia, we have considered new rock mechanic in Malaysia. So it is our responsibility. It's not my responsibility only, but it's our responsibility to introduce or to give exposure to Malaysia about, you know, when we are dealing with tunneling in the rock or weathered rock, to be more specific, when we are dealing with the rock slope and so on. Okay, and me, okay, as a woman, the only lady here, I think, I would also like to address, you know, about my family on the right side. Okay, there's the main family, of course. The on the right side is also my family, the rock engineering family. Okay, I hope to what we call it, express more about my research and also my practice in next session. Thank you.
Thank you very much, Dr. Rini, for a short introductions. So I just take this opportunity to welcome to all participants to event today. Hopefully, we're supposed to gather about 320 more or less for today's sessions. So we are in the second round of the session. We will invite all the speakers, panelists to share their experience, and perhaps they also will share some of the future challenges, suggestions, recommendations for our professions. Related to the rock mechanic, rock engineering, engineering geology, rock slopes engineering. Some of the speaker will share with us about their experience working with the underground tunnels, dams, open pit mining. Very exciting, believe me. So I hope without further ado, we would like to invite all the speakers to share shortly within 10 minutes. And of course, to all participants, please write your questions on the chat. And also, we would like to welcome all the viewers on YouTube, currently live on YouTube, to share about your opinions, or maybe to ask specific questions to our speaker. And for the second rounds, we would like to hear about research and practice, ideally how we can translate research into practice. A policy into action. So you can hear some of the issues, problems that they face in the field, and how they can use some of their most advanced theory and fundamental principle and practice in the field. So I think without further ado, we would like to invite our a great professor, prominent experience mining engineers, Professor Ridho, to kick off the second session, second round. Prof. Ridho, please.
Thank you very much, Pak Kamarul, for this opportunity. I would like to share our experience in conducting the research in ITB, especially. I will start with the topic of research. The topic of research in ITB is coming from mostly the lecturer's PhD topics. Beginning, I would say, middle 90s, we have our senior, Pak Made and Pak Irwandi, coming back from Nancy in France, bringing with them all the rock mechanics experience in research. Pamade's research, PhD research was in pillar stability, whereas Pak Irwandi is in numerical modeling. And then we have Pak Seno coming from Curtin University of Technology at that time. It is now Curtin University with rod cutting research experience. And late 90s, we have Pak Budi coming from Yamaguchi University with in situ stress measurement, in situ stress modeling. And then myself, I did my PhD in UQ, University of Queensland in Brisbane, in underground mining, especially block caving. And then Pak Ganda coming from Kyushu University with blasting ground vibration research. And later on, we also have our youngsters, Trikaryan from Kyushu as well, with topics of stability analysis of crown pillar. We have Simon coming from CSM with numerical modeling of tunneling. And just recently graduated, we have Yudi from SNU, Seoul National University, also in his research in rock cutting. So that's the resource of topics we usually practice in our institution. The second of topics resource or topic sources coming from industry. We need to conduct researches to solve, to answer the problems in community or in industry. For example, some of the industry needs the most appropriate slope stability analysis, the most appropriate underground stability analysis. So we answer that with our research conducted by the professors, the lecturers, as well as the students from undergrad, postgrad, and PhD students. Next, please. So talking about the students, this is the, I would say, the building of our curriculum, especially in, I would call it a rock mechanics stream. We have rock mechanics. In the left-hand side is our curriculum before the ABET coming to our university. I would tell you what's the ABET doing for the accreditation. So at the beginning, we have rock mechanics as the basic subject, and then we have surface mining, we have structural geology, and then we have mining geotech, drilling and blasting, underground stability, tunneling, and we only had one, one design subject, which is surface mine planning. And then thesis at that time for the undergrad still in 5 credits unit. And starting 2 years ago, the ABIT came to ITB, do the accreditation, and they request us to add more subject in underground. So we develop underground mining subject, and then we have also underground mine planning. So now the thesis itself for the undergrad is reduced in terms of credit unit from 5 credit units. Now our graduate only have 2 credit unit for the thesis, because according to ABET, undergrad students are not researchers, they are designers. So we have to put more subject on design and planning. So we do develop the underground mine planning to support the thesis of our undergrad student. Next, please. This is some example of our research. I cannot put it all in one slide. So I would start with rock characterization. As Pak Seno mentioned earlier, we have many researches in rock characterization, both in laboratory or in field. We have long-term strength determination in laboratory, either with UCS test or with shear test. And then we also develop still in laboratory the hydrofrac simulation to study what is the best direction of the spray in creating the fracture in the rock. We also have a number of resources for underground construction. For example, we used to have a Goodman jack. It's already gone because of the disruption when we did the underground research in one of underground gold mine in Indonesia. When we have the Goodman jack, we did some measurement of rock deformation modulus on site. We do also some research in determining the in situ stresses in field directly or indirectly in lab. We also have some research in numerical modeling because some of the students and the professors, they are numerical modeling lovers, not myself. So we took further the numerical modeling from only comparing the stress and the strength to what we call energy approach. So we calculate the energy capacity of the rock and then compare it to the energy given or induced by the excavation process. We also have stability analysis based on empirical approach. You can see in the middle of my slides, capability analysis. We use this capability curve to determine the stability of one of the stope in the gold mine in Indonesia, which is a very good result where we can give the mining benefit by producing much more gold ore comparing to the plan. So all the researches are conducted by our students and our researchers also. So, but with the ABET now, the main team member of the research only for the postgrad student, because as you see in the ABET undergrad student is not a researchers, but they are only designer. So that's it, Pak Kamarul. I took 10 minutes, 54 seconds. Thank you very much.
Thank you very much, Pak Rido, for sharing with us. I do believe 10 minutes is not enough for him to share with all his experience, particularly dealing with this academic world, as well as how he used his theory, fundamental principle, and test it in the real environments. And I'm happy to hear, to see some of the changes that you have made in the curriculum related to this underground mining topic. I think congratulations to your faculty, ITB, for great transformations. I think we have to admit to the needs and demand by the industry. So there was some reason, of course, behind the move, but I think it's always is a positive reactions by the industrial players. Of course, we would like to welcome all the participants. So kepada semua para peserta, kita alu-alukan pertanyaan, persoalan di dalam bahasa, and we try to translate and deliver for the sake of our multi culture, multi countries participants today. So I think without further ado, we would like to move to a second panelists. Panelists from University Science Malaysia, who also at the moment is a rock science representative in Malaysia, and we would like to hear his opinions about the current and future directions for engineering rock mechanics. Without further ado, I would like to invite Associate Professor Engineer Dr. Muhammad Ashraf to deliver his speech, please.
Okay, thank you very much, Dr. Cameron. And then in the first slide, so I would like to highlight what is actually the current state, especially in Malaysia and also basically in this region. And the first aspect that I would like to highlight is about the government funding and private funding, especially for research and development, research and innovation in Malaysia. So in Malaysia, actually, mainly the research from government is coming through the Ministry of Higher Education and also Ministry of Science and Technology. And we can say that for rock mechanics and rock engineering, particularly in Malaysia, so I can say that the budget is still considered quite small because we have also limited infrastructure development in Malaysia that involving rock mechanics. If you compare like for like in Indonesia, for example, you have a lot of minings, underground mining, open pit mining, and also in Japan, they have a lot of infrastructure project that involve infrastructure in rock, for example, like tunneling, roads, and nuclear repository, etc. So they have a lot of budget that have been pumped in into this field in order to make sure that the infrastructure developed is resilient and also sustainable. Not only for engineering purpose, but because some of these countries also have a disaster like earthquake, volcanic eruption, typhoon. And we can see also still now, for example, like the disparity from the region, a lot of budget, for example, in Europe and also in American country, like in Canada and Scandinavian country, for example, a lot of budget have been provided by the government, also by the industry, in order to produce more high-end research, okay, in this field. So we hopefully that we would like to see, for example, in the next 5 to 20 years, so the trend for research, development, and also innovation will increase in Malaysia with coming several projects, for example, like the East Coast Railway Link, where now have start back the construction. So there is several tunnel will be involved, and hopefully the industry and also the government and also the academic field can work together because if not, we left the data only by the consultant or by the contractor, and we cannot use it also for research purpose. Okay, and take example like one of the previous big project in Malaysia, the Pahang Selangor Raw Water Transfer Tunnel. The government agency and the private agency have a willingness to share most of the data for the construction work. And in USM only, we have managed to produce 3 PhD students by using that kind of data, and also several master students. And I believe also similar situation in UTM also, where we can utilize this case study data in order to produce more postgraduate studies that have measuring and specializing in this field. And another issue is also in this region, either some of the private companies have also the financial capacity to invest more in research. If we look example, I think in Korea and also in Japan, so they have a major contractor that also at the same time they have their own research center that producing new technologies, state of the art, for example, new construction methods, new investigation method, new testing methods, that also they share with the government agency and also the university. But for the time being, I can say that the initiative, especially from a private company, especially in Malaysia, still lacking. But we understand that because the projects, the infrastructure project that involve rock mechanic asset in Malaysia is also very limited. So hopefully, I think in near future, maybe private companies can play more important role, especially in collaborating with academics and also government agency, in order to provide some also financial capacity to develop, for example, new methods, new research that not only beneficial to Malaysia but also in this region. So we believe that, for example, like GMT, Cik Rashid, I think will elaborate more, have also provide a lot of platform for collaboration. But we hope that more players also can come in the near future, for example, to not only invest in terms of money, but also in terms of knowledge, experience sharing, and also providing opportunity place for student internship, okay, in some of the project that they are involved. And the second part is I would like to highlight also about the large scale testing facilities and some of the long-term studies. So if we look the trend worldwide, especially in Japan, Korea, European countries, Scandinavian countries, where a lot of research work in rock engineering, rock mechanics have been carried out when they start to think to develop what we call the high level waste nuclear repository. So when the high level nuclear waste of repository start in the development stage, I think for the last 10 to 20 years, so we can see many countries have developing their own underground research laboratory. So in this underground research laboratory in different geological environment, so they can test many new methods, also existing method. For example, not only in rock mechanics aspect, rock engineering aspect, but also the groundwater control. For example, like we know that the high-level nuclear waste repository is very highly radioactive for very long time. So they need also to identify the stable geological environment, and also to produce state-of-the-art groundwater control system in order to ensure that if the nuclear waste cannot interact with the surrounding geological environment. And hopefully, I'm not sure that Malaysia and Indonesia, I think until now, maybe not yet decided to go to nuclear power energy, but maybe we could have some research, large-scale testing facilities, or maybe underground research laboratory that we can share together. And of course, the most important problem is the budget. And in some other countries, developed countries, for example, in Japan, the government also play a very important role in order to provide, for example, like funding to the private sector and etc. in order to develop this kind of facilities. And also we can also share some, for example, facilities together between university and industry. For example, some of the equipment in rock mechanics is very expensive. So how in this problem, so we can also share the technology, share the research across the agency. Okay, so this is also another important aspect. And also, how will international cooperation evolve? For example, like we know some big funding before, like JICA and etc. So now they are focusing more on the social aspect, research, etc. So we have some limited also budget for international cooperation, and we should think also how, for example, ISRM, and through the consortium, some of the consortium of companies in other countries can also provide some opportunity, especially in developing countries, in order to further boost the international cooperation, where we can go to certain countries that have state-of-the-art equipment in order to use the facilities for our research. And back to this, so if we refer to the slide on the left side, so how actually the role that academic, private, and government can play. So either each of the slides is very important, equally important, or some part of the agency need to play bigger role in order to accelerate the research in rock engineering and rock practice. And the most important thing, if we, for example, my experience in Japan, so the private, the government, and academic, they share a lot the research finding, they integrate a lot the resources, okay, in order to optimize the resources available in the university, the government policy, and also private. So we hope that this kind of ecosystem can also be further developed, not only in Malaysia, but also particularly in this region. And for education in rock mechanic and engineering geology, I believe that because in Malaysia we don't have specifically the mining engineering school. So for example, in USM we have the School of Engineering Material and Material Resources, where they produce a number of mining also engineers. So we should have also benchmarking, I think, within the local and international university, because I think many universities now start to incorporate rock engineering as part of the core subject and also elective subject in their even in civil engineering curriculum. And either we should also refer or maybe asking some assistance from ISRM in order to provide the standard curriculum that we must refer to. And for double degree and MSc, I believe that we can strengthen cooperation in this region. For example, like Indonesia, Vietnam, and etc., in order to have some consortium in order to produce more integrated and also holistic consortium to produce a postgraduate researcher that able to work also globally. And the last part is how we also should inter and intradisciplinary provide the research and education in rock mechanics and rock engineering, because now we can see that rock mechanics, rock engineering knowledge alone is not sufficient, but we need also some expert, for example, from computer science, computer engineering, image analysis, for example, to incorporate the element of IR 4.0 into the education in rock mechanics and engineering geology. Okay, so next. Part of our research in rock slope particularly is we are focusing, for example, at USM and also in Malaysia. So part of it is what we call the rock anisotropy, which is one of the well phenomenon that related to the heterogeneity in the rock mass. And we know that this continuity in the rock mass is very important because it don't have the same and similar strength to the intact rock. And of course, the strength and discontinuity of the discontinuity will induce the rock slope failure. So we can see that now by using some new technologies, for example, UAV photogrammetry, the terrestrial laser scanner, and some of the image analysis using the cloud compare and other software, so we can optimize also the works in identifying the direction, the orientation of the joint discontinuity. But at the same time, as Encik Mak Foh explained in the beginning of the lecture, so the fundamental concept is very important, where we as a practicing engineer or researcher need to understand the fundamental aspect. For example, the constitutive model, the input properties must be correct. But of course, when we deal with rock, is not that the uniqueness is important, but we need to understand the influence of the spatial variability, because we know that the rock mass is a heterogeneous material. So we cannot rely on very unique parameter as input. So for example, probabilistic sensitivity analysis will play a very important role. And nowadays, with advancement of computer technology also, we can see that 3D slope have become a new norm. I believe especially in mining engineering, where many companies now have started to utilize the 3D slope stability in order to more reliably model the zone that will be filled. For example, we can see some in the slide. We can also locate which region that we have, for example, FOS less than 2, less than 1.5, and etc. Okay, and also, for example, the virtual reality, we can share the result not only through the computer, but also the client or the other counterparts, research counterpart can also visualize the result by using, for example, Microsoft HoloLens, where we can see the virtual reality of the site, and we can collaborate more efficiently in order to produce a better result. So the next slide, I would like to highlight also the importance of micromechanic rock modeling, especially in the fundamental aspect of the rocks. Okay, for example, like in this slide, there is a study which is a collaboration between USM and also Kajima Technical Research Institute, where this is a part of the bigger project, for example, to study the rock environment under the high in situ stress state, which can lead to the rock overstressing and rock burst. And this sample for this study obtained from the previous project in the Pahang Selangor raw water transfer tunnel, where several of the sample was taken from the overburden depth of 1.2 kilometer, and the rock is very fresh. And also similar comparison study have been done by taking the sample from the Shinkansen linear tunnel project in Japan to connect Tokyo to Nagoya. Okay, and we know that the development of the fault and, for example, shear fracture system over broad range of temperature, pressure. so can involve the growth and also crack initiation, the growth and also the interaction of the crack. So for example, in this study, we utilize what we call the acoustic emission methods to visualize the micro crack growth and also to understand, to evaluate the phenomena associated with the brittle fracture in the rocks. And by understanding the micromechanics of the intact rock part, so we hope in the near future we will apply in order to understand how actually we can detect the crack initiation by using the acoustic emission at deep geological environment. So in this study, we utilize the facilities at Kajima Technical Research Institute in Japan, where they have the advanced rock triaxial testing with AE measurement, and at the same time also we using particle flow code 3D, which is the bonded element methods, in order to understand the behavior of the intact rock, especially when subjected to the high in situ stress state. So using AE and also the PFC, so we can clearly understand the crack initiation process. For example, the shear force, the shear failure, the tension force, the tension failure, and also the number of broken bonds of each particle in the particle flow code, where we can count also it as a AE count number, and also compare with the AE measurement system that incorporate in the rock triaxial testing. So this is still in the initial stage, and hopefully this system will be applicable for practical purposes, where we can detect the crack initiation from the beginning before the failure occurred, for example, violently. So I think this is for the first round. So thank you very much, and I'd like to pass back the floor to Dr. Kamarul.
Thank you very much, Dr. Ashraf. I wish to hear more, even more, Dr. Ashraf, your experience, your knowledge with respect to these rock slope assessments. And you did discuss about the issues from the academic world and how you practice, how you use those knowledge in the practical world. And I hope that some of our participants will please use this opportunity to ask directly to Dr. Ashraf. You can type your questions on the chat box, either on the Zoom platforms or YouTube's channel. So Dr. Ashraf, we wish to hear more insight about your experience, particularly dealing with these rock mechanic, rock mass characterizations. You did share some of the tips and tricks to handle this and utilize the advanced technology, not only on the data collections, but also on the laboratory and modeling perspective. Thank you very much, Dr. Ashraf. So I think we are running out of time. Maybe we would like to move quickly to the third panelist and the third speaker, Dr. Iman. Are you ready, Dr. Iman? Well, it's a dialogue, but we try to arrange in the forms of a series of sharing by the speakers and panelists, and later we invite some of the speakers to also add some additional input based on the questions raised by the participants. So I think Dr. Iman is ready. The floor is yours, Dr. Iman.
Oke, Pak Kamarul, terima kasih atas waktunya. So here is some highlights of challenges and also potential research in. So basically the pit design optimizations basically is to get more ores safely and also productively. And also achieve the best mining and processing recovery from the mining projects to The second one, as the pit getting deeper, to do transition to the underground mines. So basically the transition from the significant or tremendous challenges which need to be managed in terms of like the geological, geotechnical, and hydrology issues. The other part is like the blasting optimization. The blasting is not only to achieve pit or dam design as expected in the mine planning design, and also the challenges is how we provide the specific requirement. Say, for example, how to control our blasting to provide specific fragmentation for our mine closure and also reclamation program. So basically, beside controlling blasting outcome in terms of like the stable slope and also less potential rockfall from our designs, also we have to control the input or outcome from the blasting activity itself. Next, Pak Mustaqim. Okay, this is showing some pictures. Bapak Ibu, you can see in the left pictures, this is the example of our slope optimization program. The left picture showing that the slope, I mean the interim slope angle can be steepened up to 5 to 8 degrees from the original plan. So basically it requires good and intensive collaboration among different disciplines. Say for example, mine planners, geotechnical engineers, hydrologists, geophysicists, geologists as well. So as you can see at the left pictures, we can see very tidy and also quite steep. This is one of the steepest mining slope in the world. So basically, what I can say is for 2 years program, 2017-2018, we can make like the steeper slope 5 to 8 degrees more. 1 degree equal is additional value up to $200 million US. So basically you can multiply 200 million US dollar by 6 or 7. So basically we get more than 1.3, 1.4 billion US dollar by the steepening the wall. So this is one of challenges what we try to do to optimize our slope designs with collaboration from different disciplines. The middle picture showing, as I mentioned earlier, about the transition from the open pit to the underground. So the 4 pictures in the middle showing, say for example, the transition from the open pit to the underground. The layout showing like the plan view of the open pit and also underground extraction layout. And the right one showing how like the seismicity from both open pit and also the underground mine need to be managed to ensure the workers are safe to work and also to provide not only safer and also productive mining operations. So basically we try to combine both monitoring from the open pit and also the underground. And currently we rely on the radar monitoring from the pit and also seismic monitoring from the underground to provide our working criteria or protocols to ensure safe and productive mine operations. And 2 pictures in the right. So basically this is quite small, but at the right upper showing how we manage the rockfall in the mine. So basically we cover all the slope by the mesh to ensure that the worker safe enough from the potential rockfall. Since we already optimized the slope, so basically we don't have enough catchment to catch the rockfall. So basically we have to combine with the meshing all the slope. And right below picture showing like the fragmentation, the fragmentation result from the blasting. Basically, we try to control our blasting design, but not only to get stable, tidy, and safe slope, but also we have to control the outcomes in terms of particle size distribution. It is critical for special project. As I mentioned earlier, it is critical for fulfill our design plan in terms of like the main closure or reclamation projects. Next, Pak Mustaqim. Okay, this is challenges and future research in the underground mine. So basically, we want to get bigger and deeper. So basically, once we get deeper to the underground and also bigger, it will create like the significant or tremendous challenges from applied rock mechanics or rock engineering standpoints. How we control the cave propagations, large excavations, and also mining induced seismicity are the critical factors related to how we operate the underground mine itself. Real-time monitoring, of course, through seismic monitoring and different type of scanning system are other challenges for us, which to optimize, basically to provide like the safe working criteria or TAPs, trigger action response plans, to secure our people who work in the underground mines. We also deal with the specific ground for drifting or tunneling. Say, for example, weak ground, squeezing ground, and also some of the water is having less pH, basically becoming an issue in terms of like the corrosions, and also need to be managed in terms of like the specific ground support requirement. The other one, what is the other challenges is about the potential wet mark and also madras. As you know, we do the transition from the open pit to the underground. We have a big catchment area, more than 4 million square meters. With the rainfall in Papua is more than 4,000 until 5,000 square meter. Basically, we catch a lot of water, and also all the water just directly going to the underground mining operations. So basically, these challenges not only endanger the people who work in the underground, and also creating some challenges in terms of like the productivity of underground mine. Just for information, that once we use like the autonomous ladder or remote loader from the underground operation, we reduce our productivity 30 to 40% comparing to our manual loader. So this is also not challenging in terms of like from the geotechnical challenges, but also the challenges in terms of safety and also productivity of the operations. Next, Pak Mustaqim. Okay, this is the last slide. So left picture showing the typical of like the underground layout. Currently, we manage more than 5 to 550 kilometers active underground tunnel. So basically, that's what we have to deal every single day. We have to manage that one since our mining is get deeper. So seismic is become real or tremendous challenges. Also like the water, how to control the water. So the left pictures, two pictures at the left side, are just showing the example of our portals and also railway. So one of our mine utilize like the rail system to support the production in the Graceberg block cave mining operation. Two pictures in the left, two pictures in the middle, showing this is our typical scanning. We do have several type of scanning. several of them is become real time, and the other one is like the seismic monitoring. So basically, this is the monitoring what we rely on for supporting underground operation, especially for the microseismic monitoring to secure the people and do evacuation once the working criteria has been achieved. So the right pictures just showing the project, we call it like the hydrofracturing. We do drilling 300 to 400 meters, and after that we provide high pressure of water to the tunnel, to the holes. Basically, the idea is to weaken the rock mass. Why we have to weaken or soften the rock mass? Basically, to get finer fragmentation, to get more productive underground operation. However, from this project also we get some benefit. Basically, this project also to dissipate the concentration of seismic and also high stress concentration. So this is like the collaboration in terms of like the mine planning standpoint and also rock mass or applied geomechanics projects. And the last one is just showing the pictures, jumbo drills in the typical of drift. So basically now we develop a drift is around 1 to 1.5 kilometers per week. So that's the quite massive development program in the underground. I think that's all. Terima kasih Pak Mustaqim.
Terima kasih banyak Bapak. Thank you very much Dr. Iman. Very exciting presentations, Dr. Iman, from the practical point of view, and you have listed 6 challenges and future research, and you shown us one the steepest underground mining that you work with, and all the difficulty challenges that you face, and how you use the knowledge in related to this rock mechanic, rock engineering, all type of the disciplinary come together and solving the issues on 2 things. First is saving a people life, and also protecting the business asset so that you can have more productivity. I like the words of this mining deeper and bigger. So I hope that in the next cycle we would like to hear some of the newest or advanced modern technology that you implement in the mining environments, not only radar and seismic, perhaps some other technique that could be beneficial for our future generations. Inshallah. Thank you very much, Dr. Iman, once again. Now our time is 11:26 in the morning in Malaysia time. So means we have about half an hour before we close, we end. So technically speaking, we are running out of time. I would like to encourage all the panelists and speakers to read the chat box to have a look at the questions, so that in the next cycle we may go quickly to answer the questions raised by the participants, and also to somehow conclude and giving some recommendations. Yes, I think we still have 3 more presenters and panelists, and without further ado, I would like to invite our future leader, I think now who's leading many initiatives in Malaysia. And we would like to hear from Mr. Rashid, who is currently a president of the Geology Society of Malaysia, GSM, and also a vice president of Society for Engineering, Geology and Rock Mechanics in Malaysia. So Mr. Rashid, floor is yours. Appreciate if you can finish within 10 minutes. Thank you.
Thank you, Dr. Kamarul. Okay, I will touch on several engineering projects that related to rock engineering, like Dr. Ashraf mentioned earlier. rock engineering works in Malaysia is not really common, but there are projects that involve rocks engineering actually. I have three category: tunnels, dam, and rock slope. So rock slope is cover for infrastructures as well as for mining activity. Tunnel we have I think as early as 1970s, the infrastructure tunnel for road tunnel in Karak Highway completed in 1979. And then our first dam also involved heavily with rock engineering, rock excavation, tunneling, etc. The first dam in Malaysia, I think, completed in 1958, which is the Kelang Gate dams. Yeah? And then we have many rock slope along the highways as well as in the mines. Next slide, please. Okay, this is tunnels and cavern. Cavern is underground space. Basically, we have recently we completed MRT 1, Sungai Buloh Kajang. And then we are into MRT 2, if you see on the left, top left, in KL. So we are into LRT 3 also. Earlier rail system, we have LRT 1, Putra, LRT 2, Star LRT, and then now we have MRT 1, MRT 2 under construction. We do hope that we can have LRT 3 and MRT 3 as well to be constructed within Kuala Lumpur vicinity. The interesting part of this MRT tunnel is we use TBM, and then now we are into variable density TBM. It is among the few in the world. Okay, so this is very interesting project for rock engineering practitioner. And then left bottom is Pahang Selangor Raw Water Transfer Tunnel. I think Dr. Ashraf also mentioned about this project. He managed to produce 3 PhD students from this project. Is the deepest and the longest tunnel in Southeast Asia. Is a combination of TBM and drill and blast in ATM, especially on the portal side is using an ATM, New Ocean tunneling method, and then in the middle they use TBM. So this is a very long under the main range of Peninsular Malaysia. And then we also have underground sewage treatment plant in Pantai. I also not very sure actually this project, but it's already completed. So we are moving into this. I think in Singapore, so they have underground sewage treatment plant. And then on the right bottom is Ulu Jelai Hydroelectric Power Underground Powerhouse. So we also have underground powerhouse in one of the dam completed not very long ago. I will touch on the dam aspect also after this. So it's going to be very interesting. And then Dr. Ashraf also mentioned about nuclear power plant. Actually, we already have power council. I mean, nuclear power council. They already identify several area to construct nuclear power plant for Malaysia. Actually, I cannot tell where is it, but I involved a bit on the investigation, identification. But due to political reason, I think they stop for the time being. So if this materializes, yeah, it's going to be very interesting for rock engineering practitioner. Next slide. Next slide is on dam. This is storm water management and road tunnel. I think this is the biggest achievement of tunneling community in Malaysia. multi-award winner. You can see, you can get all the information, all the videos on the smart tunnel from National Geographic Channel, Discovery Channel, or many YouTube channels. Yeah, this is combined stormwater management and road tunnel. During dry, when there is no flood, we can use this tunnel as a road tunnel. But when there is high intensity of rainfall, then this tunnel will be closed and transferred, become stormwater management to what they call it, to prevent Kuala Lumpur flooding in Kuala Lumpur. So this is not only smart in terms of the name, but in terms of application as well. Next. So next is a dam. So we have about 52 large dam. Large dam under ICO definition is 10-meter height, and then there's several other criteria. So, and then 21 dams are for power generation, 31 for water supply irrigation. So I just want to touch on the several dams that involve heavily with rock engineering. Ulu Jelai hydroelectric dam actually is they have underground power station, as I mentioned before, and then in fact they have one fault also crossing near the dam, so it's very challenging in terms of construction of the dam. And then we have Kenyir Dam. Kenyir Dam on the top right. So beside the dam, we also have several tunnel for power generation. Yeah? And then we have Sungai Selangor Dam, where I involved with the grouting works, instrumentation, as well as diversion tunnel. They have temporary diversion tunnel because they cannot stop the water from flowing. About 800 meter drill and blast. Then after completion of the dam, they seal back the diversion tunnel. And then on the bottom right is Bakun Dam, one of the biggest dam in Malaysia, with a lot of I would say what do you call it, resistant, not only from local but from international, due to many reasons. So that political part of it, I'm not going to touch. We only touch on the technical part. Next is rock slope. The next slide, rock slope. Yeah, this is the last slide. We have many slope, many rock slope pass through these highways. We have many highways in Peninsular Malaysia. One of interesting is on the top left is Gunung Pas, Sempang Pulai, Kampung Raja Road. This is towards Cameron Highland. If you're familiar, familiar with Cameron Highland. So this is a very classic example how geological factor really controlling the stability of the cut slope. So you need a combination of geologist, engineer to solve all this problem. And interesting, if I can recall what Professor Risat, the current president of ISRM, when he did his when he presented his short course in Kuala Lumpur 3 years ago. So he mentioned about the soil and rock characterization. So when to use soil mechanic, when to use rock mechanic. So it's very interesting observation actually. And then on the bottom left we have Bukit Lanjan. Bukit Lanjan, the rock slide field. So it's not kill anybody, but in terms of losses, actually this is among the biggest losses that due to the rock slide or landslide, because the road closed for almost a year, and then a lot of economic activity affected by this closure of these major roads. Yeah? You can see the big block is as big as bungalow. So this is another interesting study actually. If a rock engineering practitioner want to do or research want to do research, I believe there is many other factor that not been dig out that contribute to this failure. And then on the right right bottom is Jelapang rock slope. It's a granite rock slope. I think interesting figure in this region, tropical region, Malaysia, Indonesia, the same is weathering effect of our rock slope, where to use soil mechanic, where to use rock mechanic, how to characterize the mass and the quantify rock mass, thing like that. Is very interesting actually if we can really sit down and look into it. On the top right is Sling Sing mine. Currently we have only 2 mines that open pit, open excavation, Sling Sing for gold, and then we have another one is Raman Hydro mine for and then the other mine is a surface mining, real mine. So this is I think the 2 biggest open pit mine that still operation. Interesting is mainly in metamorphosed sedimentary rock. So a lot of stability as well. I think with that, I want to conclude 4 challenges in terms of practitioner. One is quantification and characterization of rock mass, especially in this tropical region. We can see a lot of weathering, thing like that. Number 2 is weathering also. Soil versus rock is also an issue actually in tropical region. And then number 3, difficult ground. Difficult ground, we have construction over anthropogenic material. And then we have also issue on collovium, beam rock. I think Dr. Rini will talk on beam rock. It's an interesting topic by itself. And then fault zone. We often neglect fault zone actually. In Kuala Lumpur, in certain area in Peninsula Malaysia, there is a lot of fault zone. Is not active, but the fault zone itself is a very I would say problematic zone for construction. And then lastly is a geological model. So internationally, geological model now become a very what do you call it, tool for sorry can somebody mute the other person? Okay.
Sorry, Mr. Rashid. I just want to make a reminder to all participants if you can mute your audio so that we can clearly hear our speaker. Thank you very much for your patience. Thank you. Please, Mr. Rashid.
Okay, the last one is a geological model. I think geological model become essential tools now in pre-development of any engineering project, so that we understand the ground better, so that we can foresee any geohazard in the ground for our development, construction, etc. I think that's all on the overview of rock engineering practice in Malaysia. I pass back to Dr. Kamarul. Thank you very much.
Thank you very much, Mr. Rashid, for the presentations. We appreciate your knowledge, your sharing session. Well, of course, it's a very short, and we wish to know more about your experience, especially related to this national case study on tunnels and caverns, dams, and rock slopes as shown on the screen at the moment. But I do believe these are just a start. So I hope that through these platforms we can do it again in the future, so to exchange our experience and perhaps some of the problems that we solved in the past, which may relevance to our neighboring countries. And I like the words that you use, between soil and rocks. So there's certain elements of research, subject of research to be embarked on, particularly dealing with the weathering rates, weathering situations in the tropical region. Thank you very much, Mr. Rashid. I hope that you can have a look some of the group chat. There are some questions related to the presentation. I hope that you can tackle in the final rounds later on. So I think I would like to move on quickly. We still have two more presenters. I would like to invite Associate Professor Dr. Imam to deliver his short sharing session and follow with Dr. Rini as a last speaker. Please, Dr. Imam.
Okay, thanks again. In this second round, okay, let me start with the first part of our experience regarding development of engineering classification of weathering grid. It is, as far as I know, also presented by our colleagues from Malaysia. Well, talks about weathering, I think it is very important in our country, especially in Indonesia, with lying on the semi-tropical equator region. And we have very intense weathering processes. And in general, it's expressed by thick residual soil that shrink individual thickness reaching more than hundreds meters. It is quite common. We can find in Indonesia. And in this regard, we developed some important indicator and suitable and reliable techniques, which are most applicable in Indonesia, especially those based on the assessment of degree of discoloration of rock material, and including rock mass. And we also identify the changes in mineralogical composition, especially from laboratory analysis. Also, we analyze the destruction of original rocks texture and fabrics. So we compare between rock soil ratio to develop this degree of weathering. And another important parameter is the intensity or fracture spacing or discontinuities. Then related with this, we still continue in developing advanced method for better classifying weathering grade using many kind of integrated physical, chemical, mechanical analysis. And actually, this weathering classification system has been made for useful guide in many engineering works in Indonesia. And also, as we know all, maybe this procedure actually already suggested by International Society for Engineering, Geology, and the Environment, and also International Society for Rocks Mechanics. That is the first experience. Let's move in the second experience, which regard to improve slacking index test for characterizing clay-bearing rocks. This analysis, this activity actually driven by many problems with regard to rapid growth infrastructure lately in Indonesia. And we have presence clay bearing, or we call as argillaceous rocks, that showing physical deterioration behavior with pacing on time, and we often call as a rock slaking behavior. And due to this behavior, many slope instability and also foundation problems arise in many infrastructure development, such as in Cipularang Toll Road in the West Java. And also we have a problem with regard to this behavior in Semarang Solo Toll Roads, and also actually in many other places in Indonesia, from Papua until Aceh region. I think our important contribution to studying the second process by suggesting the so-called as improve slaking index test. The basic test is to determine the progression of slaking through 5 cycles of the test, and implementing observation directly during the test. And we suggest a new index test for the slaking index test, called as a slake susceptibility index. We still continue to research an application of the index test widely in Indonesia for characterizing argillaceous rocks, and bring it into engineering consideration in many engineering projects in Indonesia. Then let's move in the third, our experience. I would like to share our experience with regard to integrated rock slope stability analysis for slope management. Actually, we have main application in Central Sulawesi, especially along 30-kilometer long segment at Tawali Toboli National Road of Central Sulawesi. As we know, in that region, topography is very rough, with steep and very steep slope. And this area laying on the metamorphic rocks and also molasse deposit, we already write the result of this analysis into a paper entitled Towards Development of Slope Management System along the Tawali Toboli National Road segment, Central Sulawesi. And actually, in this regard, we make a modification from rock hazard rating system suggested by Pearson 2005, and we give also some modification and integration the use of empirical continuous slope mass rating that suggested by Thomas. You can see some figure that related with the continuous slope mass rating in my presentation here. And in conjunction with analytical method, of course, using conventional limiting equilibrium method and also numerical methods. And in this regard, we also suggest the slope stability inventory method for development of slope database. Of course, we still continuing develop this analysis by integrating this method into a web-based slope risk management system. And the last research experience that I would like to share today is related to runoff distribution modeling of some debris flow in Indonesia. And talk about the landslide, I think Indonesia also is a very prone country from this disaster. We have many landslides that occur especially in during rainfall season, and we have intensive weathering process, so that's why landslides is can be found in many places in Indonesia. And one of the important landslide type that often causes a lot of casualties and very heavy damage is debris flow. And I say this type of the debris flow as a most dangerous gravity killer in Indonesia due to the lot of casualties. From this regard, we do modeling. Of course, we applied the concept of the modeling based on the momentum equation and flow mode, continuity of the flow model, and also reverse erosion and sedimentation process during the flowing mechanism. And we have already make 1D and 2D simulation modeling that applied to a lot of debris flow even in Indonesia, not only in Java area, but also that happen in Sumatra, Sulawesi, and Papua, and the big island in Indonesia. We are on progress to continue developing this modeling on better deterministic and also probabilistic approach under volume changes behavior. I think that's all. Some of our experience on the research practice in rocks engineering I would like to share today, and thank you very much.
Thank you very much, Pak Imam, for interesting talk today. And I understand the limited times may disturb some of your interesting slides that you prepared for us today. I think Dr. Imam just shared with us about some of his advanced research related to the weathering, a great classification system in rock engineering, but of course he presented about the slate susceptibility index, which can be improved with respect to the localities perspective. And I like the story of this web-based risk management system where you banded some of the rock hazards informations, as well as this last one on the run-out distributions modeling of some of the debris flow in Indonesia, where you wish to extend this probabilistic modeling in the future. So I wish you a good luck. Thank you very much, Dr. Imam, Head of the Engineering Geology Faculty of Earth Sciences and Technology from ITB. Thank you for your sharing today. So, well, let's move to the last speaker. We keep it the last one so that everybody got excited. But the only ladies in the list of the panelists, Dr. Rini, are you ready? Yeah, so I hope that we can hear some of the new insight, story, experience from the academic world as well as from the practitioner world. So without further ado, Dr. Rini, the floor is yours.
Thank you so much, Dr. Kamarul. So again, right, so for this cycle, I would like to begin, right, the presentation in terms of the academic programs offered in university or public university in Malaysia. Like we have here in the University Technology Malaysia, University Science Malaysia, University Malaya, okay, National University of Malaysia, University Malaysia Sabah, University Malaysia Pahang, and also University Malaysia Kelantan. Okay, so we can see that the major program offered is more on the civil. Of course, there are other programs offered, but now I'm trying to focus on the civil and also the geoscience or the geology programs. So we can see here that the most of the university offered the Bachelor in Civil Engineering, okay, together with the Bachelor of Science in Geology, right? And some of the universities, they offered the other subject, other programs such as the Bachelor Science in Natural Resource Science and also the Bachelor Engineering Mineral Resources in University Malaysia, University Science Malaysia. Okay, so here we can see that in terms of the programs, they are more focusing on the civil, which is the main, they consider as the problem solver in industry or infrastructure industry. But we have to understand that when we build the infrastructure, for example, the building or the road, it must be underlain by the geological formation. So that's where the geology inputs or understanding of the geology is important for the civil. Right, so I'm trying to talk on the civil engineering hat. Now I'm wearing the, not the geology part, but engineers or the civil engineers, there are more exposure on the structure, the building, how to design, but they do not really understand, okay, the geology when they are dealing with the rock formation. Okay, so that's why in student activities, okay, in UTM we try to have the what we call it as the field work. All right, so we can see at the right side, the bottom part. So we did the field work to the quarry and also to the nearby. There's a quite interesting site actually in the Cheras area in Kuala Lumpur, okay, where you can see that the students here, when they being on site, okay, in class we did teach about the daylighting joint and so on, but they do not, you know, really feel what is the daylighting joint. So once they are on site, they can experience the daylighting joint, meaning to say that you can see that the red shirt, okay, the student here, they covered the head with books, okay, because why? They feel that the daylighting joint is actually facing toward him. Okay, so that's why we try to expose the civil engineering student to understand more in the discontinuity or the structural geology, where later on they will dealing with during the working time. Okay, because actually we have two major event, okay, like what Mr. Rashid give or mentioned before. Okay, on the right side we have the Bukit Lanjan. Okay, the famous Bukit Lanjan failure occurred in 2003. Okay, and next to it is the Highland Tower collapse, okay, in 1993. So these two events actually is an eye opener to the civil engineer to understand more on the geology input, okay, during their design or the interpretation, because we have to understand, okay, we are dealing with the very high uncertainties where we are dealing with the rock mass. Okay, so that's in terms of undergraduate. But of course, we also offered some postgraduate program. For example, in UTM, we have both master in top course and also the research base, okay, in geotechnical. Okay, and also we also offered the PhD level, okay, for those interested to further, you know, study in the rock engineering. Okay, so we move on to the next slide. Okay, when we talk about all right, so when we move on to the research field, meaning to say that it's not we are doing on our own interest only, but of course it need to be kind of collaboration, okay, with industry. So we have a lot of industry collaborator. Okay, we have GMT, Geometry Granite, and also from the what we call it as authorities, okay, the MRT plus GKR, GMG, and also at the international level. Okay, we have the sender mechanism, where actually sender mechanism, they provide the 3D transducer, okay, to monitor the displacement in 3 dimension. And we also have a very long relationship with National Institute of Technology. Okay, and also the Chongqing University from China, where we are trying to work out on the transparent soil and also the AE. All right. Okay, so there are a lot of research have been or ongoing in UTM, but here I would like to show some of the recent one. Okay, you can see the video. Okay, on the bottom left. I think that's quite famous. Okay, in YouTube. Okay, this is the fly rod in Indonesia, and of course in Malaysia we do also experience the same event. Right, you can see at the top left side where we have the Masai. Okay, the Masai fly rod occurred in 2013, and we have other event also in 2008 in Perlis and Ipoh in 2019. So we can see that there is a need to understand. Okay, because if we want to carry out the study, you need to have a problem that we want to search. So that will be a better kind of research where we can contribute back to the industry or to the community as well. Okay, right. In this study, okay, my student work on more on the numerical modeling. Okay, because it's hard to set up a laboratory scale of blasting. Okay, when you are dealing with high health and safety issue. Okay, and we work with the Gemachi Granite Quarry. Okay, so we carry out a series of parametric study in the discrete or the particle flow code. Okay, in addition to the LS Dyna as well. So we use the bonded particle model, right? So we try to have different parameter that contribute, okay, to the fragmentation. Okay, analysis of the rock by having series of what we call it parameters such as the spacing, the steaming, the burden, and so on. All right. So this model is still ongoing. We try to improve it, okay? So we can have more or better understanding of the fly rock condition. Right. So the next session that all right, so I'll try to highlight here is that in terms of the application of the technology. Okay, so now we know that we are moving on the IR 4.0, big data, prediction, and also the smart infrastructure. Okay, so for example, previously we used to have the conventional mapping, right, by having the geological compass and so on, but now we try to move on. Okay, we have a lot of choices actually, for example the photogrammetry, but here on the right side, okay, the top one, we can see that there's what we call it as the TLS. Okay, so it scan, okay, and it can capture by having about 1,000 data only within few hours. All right, so we can get not only the deep and also the deep direction, but at the same time we can reduce time on site. Okay, because sometimes we have kind of safety issue to work a long time on site. Okay, or we have limited access and so on. So the TLS will be a solution to the geological mapping. But of course, we cannot totally rely on the TLS itself. It needs to be verified by spotted geological mapping. Okay, and the next, I think quite interesting that we can go or move further in term is the on the geophysical method. Okay, we have few methods, okay, like the seismic or the resistivity survey. Okay, because previously we in civil engineer, okay, we like to have the site investigation, the borehole. We want to see everything in real. Okay, but it will cost a lot. Okay, and the borehole will only give you 1 point information, right? So it's good to have a combination of the boreholes and also the combination of geophysics method, because we know that in terms of the geophysical method, they also have their own limitations. So a combination of seismic and also the resistivity, we can have a good understanding or wider coverage of the subsurface profile rather than the borehole. So a combination of the geophysical, the TLS, it will be a good method for us. Okay, we can explore a lot actually from this technology. Okay, we can go try to get because we know that this information or this technology is considered new to ours. So we need to have a good correlation. How can we correlate? Okay, for example, the resistivity value to the engineering properties of the rock, right? So that's how we can move on. Okay, meaning to say we are not leaving the theoretical part, but we try to bring the theory to more like cost saving, okay, and also time saving. Okay, so that's the way move forward. And the bottom part is I would like to share on the tunneling activities in Malaysia. Okay, I believe that Mr. Rashid has explained a lot about the tunnel that we have, okay, in Malaysia, and also similar to Indonesia, where now you have the MRT Indonesia already operated, and also the high-speed rail, right, connecting Jakarta to Bandung. So there'll be a lot of interesting, finding, okay, similar to us when we start our smart tunnel. Okay, that's the first tunnel in Klang Valley area. So there are two formation or the major formation in that area, which is the limestone and also the Kenny Hills, where we know that the limestone, when it's a weathered limestone, we will deal with a lot of karstic condition, right? So during the smart tunnel, actually, they have a lot of problem with the sinkholes, okay, because they are not really understand the formation in Klang Valley. But once it moved to the next project, the MRT Line 1 and also the MRT Line 2, where they start to apply the variable density tunnel boring machine, so they gain understanding about the ground condition. Okay, but that's on site process, or the what we call it as the ongoing learning. Okay, back to the what we have before, which is on the left side. Okay, this is part of the what we call as the settlement prediction. Okay, so we have commonly used, okay, using the green field, meaning to say that the tunnel is excavated without any what we call it loading. Okay, we consider as a green field. And okay, we can see in terms of the settlement, okay, that predicted is far below than the actual settlement. Okay, meaning to say there must be some kind of improvement need to be carried out in terms of the prediction. Okay, meaning to say we no longer can estimate in terms of the greenfield condition, but we have to move on. Okay, we need to start to have a prediction with the urban area where we are dealing with a lot of building, the loading, all right, and to indicate the subsurface condition as well, because normally the prediction is based on the depth, okay, and sometimes cover to the diameter ratio. So in near future, okay, what we have a collaborator, okay, now with the MRT and also the MRCB Josh Ken. So we try to compile with all the data, okay, the big data. We try to have a kind of prediction how actually, rather than the greenfield condition, but we move on to the urban condition, how the actual settlement should be looks like, so they can reduce, okay, the sinkhole or any settlement during the excavation. Right. I think at the same time, okay, we tried also to move on. I think there should be another. All right, okay, that one. Okay, we move on to the laboratory scale as well. Okay, so we can understand in-depth understanding by having not only the lab scale but based on the numerical modeling. So by having this transparent soil, so we try to get how the deformation actually behave, okay, and also we try to have this kind of modeling not on the green field, but we have to put this kind of loading so we can try to replicate, okay, what actually on-site experience, okay, rather than the greenfield condition. Okay, these are the two that my research or my research students working with, to go on the prediction, okay, and also using the big data. Right, so okay, I think that's all from my part. Maybe I will talk on the beam rock in the next session. I hope I can still have time for that.
Yes, thank you very much, Dr. Rini. Thank you for your very timely presentation. And I wish to hear more story about the technology that you implemented in the field and how your academic knowledge, some theoretical knowledge that you implemented in the field. And I like the quotes that you mentioned, whatever technology or advancements, we talk about cost saving and also time saving. Very interesting remarks. And I hope that to all participants, you can direct all the questions to Dr. Rini if you wish. And since we are running out of time, about 13 minutes already, than the original plan, we would like to do some little change. We would like to conclude in the next round. And I would like to invite all the panelists and presenters to prepare the final remarks. Maybe if you have some recommendations to the young engineers, young geologists, young professionals, to future generations, please do mention in your final remarks. And I wish that you can also address some of the few questions, major one, in your final rounds. So I think we would like to go to the first one by inviting Pak Rido to share with us about 1 to 2 minutes his future directions with respect to the research and practice. Please, Bapak.
Okay, thank you, Pak Kamarul, for the questions, either from Zoom or YouTube. I already directly answered the questions in the chat, so I just want to talk about the future direction. So in the future, I think rock mass characterization is still the problem to answer. From many of us today already point out this. We also need to address how we determine the rock mass long-term strength. We also need some design curves to assist our friends in industry so they don't need to do the time consuming calculation, just use the design curves based on the previous experience and from the other project. And also we need to do modeling for ones who love modeling. Can we do, for example, hydromechanical, thermal, chemical modeling and just hit the enter and get the result? Probably not, but we'll see in the future. And I would like to use this term, total deposit knowledge. So in mining engineering, when you do your planning, not only considering the cost and the revenue, but also the rock mechanics aspect in your model. So what is the consequence from rock mechanics if you go from west to east, or if you go mining from south to north, etc., etc. And just for example, if you want to think out of the box, now I have 2 PhD students. One is doing non-destructive testing for the rock bolt, and the other one, quite interesting, how we use bacteria to strengthening the soil or to consolidate the weak rock. So still many rooms for improvement, many rooms for research in the near future. That's it, Pak Kamarul.
Terima kasih banyak Bapak Pak Rido for the last point. I hope that some of us will pick up some of his suggestions, and we have to bear in mind that of course we need to still explore about these rock mass classifications, and Professor Rido mentions about this total deposit knowledge, but not only considering the cost and revenue, but also look into the consequences. Thank you, Bapak, for final remarks. So I would like to invite Dr. Ashraf, please.
Okay, so thank you very much, Dr. Kamarul. So I think we're also running out of time, so I try to go as quickly as possible. So as we have discussed, I think by several speakers before. So in this region, so the weathering is very intense, and we can see that even for rock slope or our tunnel face, when we excavated, so we facing different grade of weatherings that need to be assessed carefully in order to develop or to suggest the design for the mitigation or the tunnel support system. So in this sense, so we now focusing for imaging future research to incorporate what we call the image analysis techniques by using the computer science, computer vision, in order to not only qualitatively rate or characterize our weatherings, but also to quantitatively by using what we call the several color schemes. For example, you can see here on the apple side, for example, to identify the quality of the red apple. For example, we need to use a spectrophotometer or colorimeter in order to determine the several parameter of the color scheme. For example, in this case, the LAB value. So we know that either this apple is considered a high grade red apple or not. The similar concept also can be applied, for example, in different rocks. For example, we have a granitic weathering rock, meta sediment, etc. So we need to identify, to evaluate what is the influence of the weathering, especially the chemical weathering process and the mineralogical involved, and at the same time to identify how these changes can affect the LAB value. So we can use the image analysis technique in order to characterize more precisely the phase, for example, tunnel phase or the rock slope phase. If you look example on the bottom right side, so the conventional method normally that we use, for example, tunnel phase mapping in atoms. So the geologists need to go to the tunnel phase after blasting and then need to sketch, and this is also depends on the skill of the geologist itself. So by combining the manual mapping together with the image analysis, so hopefully we can expedite the process of the for example, the tunnel excavation sequence, and also to make more better prediction in the rock slope assessment. So next slide. Okay, another emerging future research that I think we should also looking into is the 3D printing in rock mechanics. And we can see that for the past 5 years, so many researchers have focusing on this 3D printing in order to simulate many microscopic micromechanic rock behaviors. For example, you can see many papers, for example, from China, from Russia, and also some European countries that start to utilizing the advancement of the image analysis, 3D printing, in order to produce or to replicate the behavior of the rock in the labs. For example, we can see that now many researchers start using CT scan. So we know that CT scan that we use for health also can be used in order to image the microstructure of the rocks. And then by translating or by converting these CT scan images into 3D, so we can reproduce the similar rock type, but of course with different materials. And nowadays people start using, for example, the old one, we start using PLA, and then but now we move towards more advanced material like gypsum, and also I believe in near future people will start to use nanomaterials in order to replicate or reproduce the rock samples. So what kind of research that can be carried out? It is not only research, but I believe that 3D printings in rock mechanics, rock engineering, and also geosciences is also very important in education, where we can use this technology to visualize something in laboratory scales. For example, from TLS, UAV photogrammetry, so you can capture the topography of the rock and you can print it again and maybe showing it to the students to better understand. And also we can see that some studies from Ishotov 2007, 2018, so they have start to use 3D printing, for example, to identify the behavior by upscaling the material behavior itself. For example, the pores network, the voids, and even also the micro structure of the materials. And also a lot of research also have been carried out for flow analysis. For example, in fractured rock and discontinuity networks, sometimes it's very difficult to get the real sample. So they try to reproduce it by using this 3D printer. And also some research also focus on the roughness analysis. So I believe this is some of the research domain that maybe we can also cooperate in this region and also become a pioneer also, especially in the Southeast Asian region. I think that's all from me. Thank you very much.
Thank you very much, Dr. Ashraf, a birthday boy today. Congratulations.
Thank you.
So I wish to see some of the amazing future research can be materialized. Thank you for sharing with us about the ideas of exploring into the image analysis, 3D printing, even replacing the sample with nanomaterial. Why not? So I hope well, you have a bright future and career, and of course contributing to this field related to the rock mechanics, rock engineering, and also geosciences. Thank you very much, Dr. Ashraf, for the final remarks. And I would like to invite now the last four speakers, very quick, Dr. Iman, Mr. Rashid, and also Dr. Imam and Dr. Rini. Please, Dr. Iman, if you have anything to share, final remarks, please continue.
Pak Kamarul? Halo?
Ya, silakan Bapak.
Oh ya, terima kasih Pak Kamarul. No, I just want to, just to, some final remark for me, especially for the young engineers, young geologists, just need to remember about the collaboration among different disciplines. So basically, we have to work together and to get better and productive result. I think that's all, Pak Kamarul.
Thank you very much. Very important remarks indeed by Dr. Imam about the collaborative work, about working together, and of course, with this particular industry and world, we have to work with a different disciplinary. Thank you very much for your final remarks, Dr. Iman. And Mr. Rashid, if you are online, you can deliver final remarks, 1 or 2 minutes. Mr. Rashid?
Yeah, I fully agree with the previous speaker on the collaboration between various multidisciplinary professional. I do hope that collaboration between Malaysia, Indonesia also will be increased in the near future, because like Pak Senu mentioned earlier, we have same culture, we have the same condition, geological condition in terms of tropical climates, things like that. So very interesting with this event. So hope we can see more collaboration in the future. Thank you.
Thank you very much, Mr. Rashid, for your final remarks. Our Vice President of SEGRM Malaysia, and who also a President of Geology Society of Malaysia, and recently being appointed as a Vice President, Malaysian Geoscience Consultant and Services Associations. Thank you very much for your time, Mr. Rashid. Now I would like to invite Dr. Imam for your final remarks, please.
Sorry. Okay, thank you very much for this very good dialogues. I think as can you see in my slide, I put some for the development, yeah, with regard to our research and practice in rock engineering. Before sharing, let me show also some courses that related with this development with taught at geological engineering study program of ITB. In this basic level, our student also takes engineering mechanic and rocks mechanic courses at the mining engineering study program, and we teach our student also with some opportunity to learn about rocks engineering for the application in rocks engineering. You can see about engineering geological investigation, including rock mass characterization, as mentioned by Pak Rido. And also we have soil and rock engineering course. And also I think you can see many other courses that related with this subject. And also I have put some future development in this slide that I had actually mentioned before in my presentations, in previous rounds presentation, related with the weathering grades classification and better classifying this classification and the utility of improved slacking index tests in many engineering works in Indonesia. Also, we want to integrate rock slope stability analysis. We will do deterministic, probabilistic debris flow modeling, and in addition, in the future, we would like to also develop stability analysis for tunnel and underground building that lately many projects with regard to this development of tunnel and underground building in Indonesia. And finally, we also want to develop some modeling with regard to artificial intelligence and machine learning for sensor susceptibility zonation. I think I also hope our collaboration and cooperation between Indonesia and Malaysia will be realized in the near future. And that's all my closing remarks. Thank you very much.
Thank you very much, Dr. Imam. I hope so. So through these kind of platforms, dialogues, and event in the future, we can strengthen both sides, Indonesian scientists, practitioners, professionals with a Malaysian side as well. Thank you for sharing with us about the future developments on research and practice in rock engineering. So last but not least, our Iron Lady, please, Dr. Rini. Mute Dr. Rini if you can.
Okay. Thank you so much. Okay, so yeah, I have a very short one, okay, because seems we are really running out of time. But I think the one that I'm really looking forward is in the beam rocks, okay, already mentioned by Mr. Rashid as well, because you can see that because we are in the weathering a high weathering condition, right? So we have not only the fresh rock, not only the soil, but sometimes it's the intermediate, how to treat, for example, the slope. Is it we have to treat, or we have to design, we have to analyze it as a soil, or we have to analyze it as a rock material. So this is where the beam rock terminology came from. So it's still there actually been some study have been carried out, but not yet in Malaysia. And I do hopes that in the near future, okay, we have this kind of failure, right? It's actually a beam rock, because we cannot design or model it as a soil, yet not as a rock. So because we cannot predict how the failure will occur in between soil and the rock. I think there will be a good future, okay, for us, okay, Malaysia and Indonesia to work with, because we are in the same climate condition. I believe that we have the same problem as well. Okay, and the second part is in terms of the digital infrastructure. Okay, now we are going more on the smart infrastructure. It's like when you have a car, now the car, they will tell you what they are feeling, okay, what they have a problem, okay, but not in the infrastructure yet. Okay, some of them may already apply. Okay, the car will tell where they are going to be out of fuel or something like that. But does the tunnel say that, okay, I'm behaving this kind of behavior? So this is what the next thing to do. Okay, we need to have kind of smart infrastructure, okay, so that the tunnel, okay, or the slopes, okay, they can speak before the incident or the failure occurred. Okay, some of the infrastructure like the bridge, okay, they already put it kind of the smart infrastructure. Even for the early warning system, is considered as the smart infrastructure. Okay, we have the flood mitigation, for example, the smart tunnel. Okay, they already applied. Okay, at that certain level, alert, trigger, and so on, they will give the indication. So what we need to do. Okay, so similarly that we need to move on to the slope, okay, or also the tunnel. We need to go for the digital infrastructure, but yet it's not an easy task. Okay, it seems like just putting some sensor, but of course we need to study, okay, how those infrastructure behave, okay, in terms of the threshold level, okay, what's the threshold that we need to apply, so we did not give the false alarm. So if we give the false alarm, you will understand later on the resident, for example, they will no longer, okay, or they will ignore the alarm that come out. So it seems like to be kind of straightforward. Put the sensor, understand it, that's it. But to understand what's the behavior, what's the threshold level, it will be going to be a very detailed investigation. So this is where I think that we both Malaysia and Indonesia should look at, and we may also learn, okay, from the Japan, okay, from the China or from the Korea. I think they have applied, okay. Last time we also had a visit to Taiwan, okay. They also have applied kind of the debris flow, okay, alarm system. So this is where we need to move on, okay. So a combination, okay, of our similar what we call it, problems. I hope in near future we can have more collaboration, okay. And also here, like Dr. Kamaro also addressed few times, okay, I'm the only lady here. I think it's not too late for me, okay, to say that I still remember the first time when I joined the rock family, or about to join. I mean, when I want to do my PhD in rock, one of my colleagues did mention that this is a main dominant field. So I took that challenge, okay. It's quite challenging, okay, to say it, but I'm glad to be part of the rock family, okay, and also contribute, okay. Even now, most of my teammates are the male, okay. My students, okay, also the male. I'm looking forward for the female students, okay, for me to work with. And yes, I hope that's it to end my session today.
Thank you very much, Dr. Rini. I hope so. There will be more ladies in the future. So with that, I think we come to the end. On behalf of the organizer, we would like to apologize for some delays. But of course, you know, these 130 years of work, cumulative experience, it's not easy to handle within these 2 hours of sharing sessions. I hope that we can do it again in the future. To all professionals, scientists, professors, academicians in Indonesia and Malaysia, I hope that we can initiate this kind of dialogue in the future, inshallah. So just to inform that this dialogue on research and practice in rock engineering is jointly organized by International Society for Rock Mechanics and Rock Engineering, IRSM, Society for Engineering, Geology and Rock Mechanics, SEGRM Malaysia, Indonesian Rock Mechanic Society, RRMS, International Association for Engineering, Geology and the Environment, IAEG. So I think on behalf of the organizer, we would like to thanks to all speakers, to all panelists. And without further ado, I think we come to the end. And I would like to thanks, also, of course, to our secretariat, the man behind the scene, Pak Ganda, Pak Mustaqim, thank you very much for your great support. And very quick, we would like to announce this Malaysia-Indonesia Rock Engineering Symposium, MIRES, next year in Bandung. Please keep in touch. For those who are not registered yet, filling up your particular on the online registrations or applications for your CPD, please do so in this chat box. We shared the list of the file, so please fill up your informations. And to all participants, either in Zoom platforms or in YouTube, thank you very much. Have a great weekend, and please, keep safe and healthy, since at this moment is recorded about 22.8 million cases, positive cases of COVID pandemics, and about 150,000 in Indonesia, with less than 10,000 cases in Malaysia. So on behalf of the organizer, once again, I hope that we can use some of our research into practice and translate all these terminologies, sophisticated technologies, into the societal transformation in the future. So with that, I hope that it's not too late to thanks to our colleague, our Indonesian colleague, for the celebrations Independence Day, and also to all Muslims, selamat menyambut di Ma'al Hijrah. We are on the 3rd day of the Muharram, mashallah, with a great dialogue for the new year Islamic calendar. I hope that we can together pray for great success, both countries together, all the professions work together, and I hope that we can continue this kind of event in the future, but perhaps in the different versions, maybe in the physical modes, much better, hopefully. So to all the speakers, and of course to our prominent guests, Pak Seno and Pak Mak Fo, thank you for your patience, for your support, for your great time today. So with that, I would like to close the sessions, and you can also post this recording file of YouTube to your friends who are not able to join us today. So it's a memorable moments and records for us for the future generations. So with that, my name is Kamarul Azari Razak. I would like to apologize for any inconvenience. So with that, we close the session. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Very good day. Selamat berhujung minggu.
Terima kasih, Pak Kamarul. Waalaikumsalam
Terima
warahmatullahi
kasih.
Thank you
wabarakatuh.
very
Terima
much to
kasih.
all. Bye-bye.
Terima kasih semua.
Terima kasih.